So here's an absolute value question. It's an exam question from a past paper. The number of birds bee that a bird dealer sells in each month of the year from January to December can be modeled by this function. So it's an absolute value function that it's an absolute value function that I've highlighted here already, where t is the time in months and t is equal to 1 represents January. Okay, so it's a multi-part question. First thing we've got to do is we've got to first graph the function. And then from that graph, we've got to figure out the maximum number of sales reached in 1 month, and in what month the minimum number of sales is reached. Okay, so first challenge for us is to actually graph this equation. It looks a bit daunting, right? We've got a lot of numbers, we've got a lot of transformations that we're going to need to do. But I'm going to go through step by step from the basic absolute value exam question to just to show you how we can graph it and how it's going to sort of look. Okay, to do that, I'm going to use this online graphing software. I'm going to use Desmos. Okay, so what I'm going to do is I'm going to first drop the original graph, right? So currently we have b is equal to -15, and then we have absolute value. So I'm going to do that from here. Where's the absolute value function? There it is. T minus 5, absolute value, RAS 120. Because that's our equation right now. So I'm not going to, it looks a bit like that, but I'm just going to remove that for now. What I want to do is we're going to start with the original graph. So we're going to start with b is equal to just absolute value of t. I think that's what we're going to start with. Again, we all know what this graph looks like, right? It looks sort of like a V. Anything, if you guys haven't seen the absolute value equation at all, thus you should be watching this video. If you haven't done absolute values at all, check out my previous videos on that one. But just to give you guys a refresher, this is a linear equation. You see how this is a straight line and it just goes down to the negative here. In the absolute value, remember, anything that's on the negative, it just gets reflected and becomes positive, which is what is happening here. Okay, this green part here, that's just getting reflected across this x-axis and becoming positive. Okay, so that's our original graph, right? B is equal to absolute value of t. Now the next thing I'm going to do is I'm going to shift this to the right 5 units. See how we have this -5 here? That's what that does to the graph is it shifts the graph to the right by 5 units. As I'll show you guys here. So this is b is equal to absolute value of t. And then I'm now going to show you b is equal to absolute value t minus 5. Okay. And if you have a look at that one, the difference is very marginal because they're zoomed in a lot. But as you can see here, this is our original, just b is equal to absolute value of t. And when you have b is equal to absolute value t minus 5, it moves to the right by 5 units. Okay? Now the next thing I'm going to do is I'm going to account for this transformation at the middle here, at the front here, sorry, at the -15. Okay, so I'm just going to get this whole thing here. And then I'm going to put the -15 in front. And what that does is, firstly, because it's a negative, it's going to reflect the graph across the x-axis, and then it's also going to narrow the graph by 15 units. Okay? As you can see here, the graph has just become a bit narrower. So, for example, over here, when you had 1 and 1, over here, when the x value is 1, the y value is 1. Where is it? In our original graph, in our original absolute value graph, when the x value is 1, the y value is also going to be 1. Over here, when the x value is 1, now the y value is going to be -15. Right? Where is it? Yeah, or -15. Okay? And that's a combination of us moving it to the right by 5 units, and the graph is getting narrow by 15 times 15. And then we add this plus 120 part at the end, and what that does is that shifts the graph up by 120 units. Okay? So we're going to add the 120, and that shifts the graph up. Okay? So what I'm going to do for you guys is, I want to then show you guys step by step from my original graph. So we've got b is equal to square root of, sorry, not square root, absolute value of t. First thing we do is we move it to the right by 5 units. Okay, as you can see here. Then we narrow it down by 15 units and reflect it across the x-axis, as you can see here. and then we move it up by 120 units, as you can see here. Okay, so this final part here, that's going to be our graph, or this is going to be our graph of the equation. Okay, now that's part A done, graphing the function. Now from that part, we can see that we've got a graph here. What we're going to do is we need to find out what is the maximum number of cells reached in 1 month. So that's the highest peak we reach. So that's obviously 120. Okay, that's the maximum number of cells reached in 1 month. And then part C was asking us, in what month is the minimum reach? So in what month is the minimum reach? So as you can see here, we have 0 cells reached. And if you go back to our graph, that was around, that was during 13. But we need to restrict our graph from 1 to 12, right? Because we only have 12 months in a year, and we're looking at the graph from January to December. So if we look at from this 1 to 12, if we look at 12 here, 12 is over, yeah, 12 and 15. So that is the lowest point in the graph, okay? So therefore, the lowest number of cells will be during December.